Good afternoon, friends. Uh, Today's my topic of lecture is design of flywheel. So, we will today study the design of flywheel, in which we will design the whole flywheel and we will understand its function. So, first, what is flywheel? The first, what is flywheel? Flywheel is we can call it energy bank. We can call it energy bank in which exists between power source and between any machine. So, flywheel is a energy bank between a power source and a machine. Now, we supply some input torque to the energy bank and we get some output torque from the energy bank. Now, in say this power source can be a motor, could be IC engine, and this machine could be an automobile, or it could be a punching machine. Now, this is called a flywheel. Say if it is supplying, in case of motor, it is supplying a constant power, then the machine, for example a punching machine. So, if we require a variable torque here, if we require a variable torque in the punching machine, now this flywheel will have will store the energy during the idle portion of it, and it will supply the energy to the punching machine whenever it will be requiring the energy during the punching operation. Whereas in case of IC engine, we have the energy torque which is a variable torque. We have a variable torque in this, that is input to the flywheel, and whereas in this case we require a constant, whereas in automobile we require a constant torque. So, what happens in case of IC engine? This supplies the variable torque that supplies to the flywheel, and because of some variation we require the torque at the automobile that to be constant, and that is done by the flywheel. Now, how it works? See, excuse me. Now, how it works? See, say in case of punching press, in case of punching press, say this is the torque required and this is the angular displacement theta, angular displacement, say it is the variation of torque. Now, this is called one cycle, or it is the angle is a 2 pi. Say it is between A, B, C and D. say this is the mean torque which is required or which is supplied by the motor, which is supplied by the motor, and during A to B what happens, the available torque supplied is T mean, whereas the available torque required is nil, T1, torque required is T1. What happens during this period? What will happen? What happens during this period? If you see the variation of velocity, the angular velocity, that is omega, with respect to theta will increase. So, here the velocity is maximum, it will increase of some value to a maximum value, right, and then it will decrease. Now, there is a variation of velocity from A to a B, this is B and this is point C. So, there is a increase in velocity from A to from some value, minimum value to maximum value, and then from B to C, because the required energy is very high. This is the maximum torque which is needed during the punching operation, which is needed during the punching operation. So, during this period what will happen, the angular velocity will decrease from maximum value to some minimum value, and the kinetic energy of the flywheel will decrease from this period to this period, and further from C to D it will again increase to the same value. Now, during this period, during A to B what happens, this is the from A to B, this is the period in which it will store the energy in excess of it, and during this period it will also store the energy during this period. Now, these two energy storage will be equal to, say this energy will be equal to T mean minus T1 into d theta integral from A to B plus integral from C to D between T mean minus T1 into d theta, right. Now, this energy is the energy which is input, this is the energy input, and whereas the energy output will be T maximum minus T mean into d theta into from B to C, from B to C. Now, this is called variation of maximum variation of energy. Now, this is called maximum fluctuation of energy. For example, in case of IC engines, what we have a T theta plot say it is a mean torque, the suction stroke, say we have a suction stroke, then we have a compression stroke, then we have a expansion stroke, then we have a exhaust stroke. So, if this is a mean torque, then this much energy is provided in the expansion stroke or working stroke, and we will get the maximum fluctuation of energy during one cycle, right. This cycle, this one cycle could be of 2 pi or could be of 4 pi in case of 4 stroke engine. For 2 stroke engine it is a 2 pi. Now, we know that maximum fluctuation of energy occurs between B to C. Like in case of punching press, the angular velocity of the flywheel will decrease from omega maximum to omega minimum, and during this period maximum fluctuation of energy will be there, and that will be maximum fluctuation of energy will be equal to half I omega maximum square minus omega minimum square. Omega maximum square minus omega minimum square. Now, that this is equal to u output or delta E or u output, maximum fluctuation of energy. This will be equal to half I omega max minus omega mean into omega max plus omega mean. Now, we can write this, whereas now we define here two another parameters, coefficient of fluctuation of speed, that is equal to Cs, that is equal to maximum variation of velocity divided by mean velocity. Now, maximum variation of velocity is equal to omega max minus omega mean. Now, whereas mean velocity is equal to omega max plus omega mean divided by 2. So, coefficient of fluctuation of speed depends upon the maximum variation of velocity, which is equal to omega max minus omega mean divided by a mean velocity. Now, from here we can have this delta E, which was half I. Now, difference of velocity, this difference of velocity we can write it as this difference of velocity, mean velocity into this, whereas this is equal to we can write omega, and this can be written as twice of omega. So, this can be written as twice of omega, whereas this maximum velocity can be written as twice of Cs into omega, Cs into omega. So, we can write the maximum variation as maximum variation of difference of velocity can be written as Cs into this, and the mean velocity can be written as this, and we can write this as I omega square into Cs. So, this is called maximum fluctuation of energy. So, maximum fluctuation of, on the basis of maximum fluctuation of energy, we can determine the moment of inertia. This is called moment of inertia of flywheel. Now, coefficient of fluctuation of speed could varies between, this is 0.2 in case of crushing machine, it is 0.10 to 0.15 for punching operation, and whereas its value is 0.03. .03 for IC engine. Now, these coefficients are known to you, and this can be put in this equation, and mean angular velocity is known to you. You can, if you can find the maximum fluctuation of energy, you can calculate the required moment of inertia of the flywheel from this equation, right. Now, this moment of inertia is provided by, this I is equal to is provided by the flywheel rim and hub and arms of the flywheel. Now, what is coefficient? Now, we define here another parameter, coefficient of fluctuation of energy, it is known as Ce, and it is equal to maximum fluctuation of energy divided by work done per cycle. Now, for any machine, work done per cycle is known to you, and if coefficient of fluctuation of energy is known, you can find the maximum fluctuation of energy, that is delta E, or we can write it as work done per cycle. This is Ce. Now, from this we can calculate, we can evaluate maximum fluctuation of energy as Ce into work done per cycle. Now, work done per cycle can be equal to work done per cycle is equal to mean torque into theta. Theta is the angular displacement per cycle. Now, this could be written as T mean into theta. Now this theta is the angular displacement per cycle. It could be 2 pi or 4 pi in case of 2 stroke engine, and it is 4 pi in case of 4 stroke engine. Now T mean we can find by multiplying the power P into 60 divided by 2 pi n, where P is the power and n is the speed in RPM. If you know the speed and power, you can find the mean torque, and from where you can find the work done per cycle, which you can put in this equation, work done per cycle, and in this equation, and you, if you know the coefficient of fluctuation of energy, you can calculate the maximum fluctuation of energy, right. Now we had derived this maximum fluctuation of energy equation, that is a design equation, that is I omega square Cs, in which we will use this I so basically what we have, design equation is delta E is equal to I omega square Cs. Now delta E could be written as Ce into work done per cycle, which is known to you, and this is I omega square Cs. Now if you know this parameter, if you know this parameter, you know this angular velocity, right. What you can do is you can calculate this I. Now this I can be calculated. Now this moment of inertia is provided by the flywheel. Now flywheel is a very complicated shape. Let us draw the, this I is provided by the flywheel, which you can draw here. Now see, this is a shape of flywheel in which you have to have some arms you have this kind of flywheel in which this is called a rim, this is arms, and this is hub. Now, this I is provided by the three components of the flywheel. Now, because this shape is complex, this is a complicated shape, so it is difficult to find exact mi, that is I. We can, it is very difficult to find exact moment of inertia of the flywheel. Now, that is why this is the analysis is done by having two assumptions. We can have we have two assumptions. One is either spokes and hub, that is spokes, or we call it spokes. Arms are also called spokes. Now, spokes or and hub do not provide any moment of inertia, that is, and hub, spokes and hub provide 10% moment of inertia. So, it means in this case rim provide 100% moment of inertia in first case. In the second case the rim provides 90% is provided by the rim. See, so 90% is provided by the rim. Now here the moment of inertia of the, that is mi of the mi of rim, this is equal to m r square. Now, where r is radius of rim, we call radius of rim. Now, this can be approximately written as m r square. Why? Because this this rim in this case thickness of rim is very negligible as compared to a radius. Now, so where this is the thickness T, this is the thickness of rim and this is width of rim B. Now, in this case thickness of rim, that is T, is very less than as compared to R. So, that is why we can write this I r is equal to m r square. Now, here the objective is to minimize the mass of flywheel. Now, this mass can be reduced by taking the r, this can be by r selecting the r as maximum. So, r by selecting the maximum radius we can minimize the flywheel mass of the flywheel. Now, how can we select the maximum radius? Now, this maximum radius has some limiting value. This maximum radius can be selected, it is maximum radius